Hello students, welcome back to our video lecture series for the subject Mathematics 3 for all my mechanical engineering students. So in today's lecture, we discuss about divided difference. First, we try to understand what is divided difference. Using divided difference, how we can solve some of the important examples. The formula is Newton's divided difference interpolation formula. Okay. Uh, Both the methods is Langrange interpolation formula and Newton's divided difference interpolation formula. Generally, we are using for unequal interval. Okay, unequal interval, right? So we know that the value of x is x0, x1, x2, and the value of y is y0, y1, y2. Okay, and first of all, suppose we want to define our first divided difference, for x0 and x1. So that also write f of x0 x1. Sometimes we use this notation f of x0 x1, that is equal to, sometimes we use this notation in big bracket x0 x1, that is equal to f of x1 minus f of x0 upon x1 minus x0. So we know that f of x1 is what? Y1. F of x0 is y0 upon x1 minus x0. So this can be written as this equal to y1 minus y0 upon x1 minus x0. Okay. Similarly, if you want to define the same first divided difference on x1 and x2. Okay. So now you can understand that is f of x2 minus f of x1 upon x2 minus x1. So f of x2 is what? Y2 minus y1 upon x2 minus x1 and so on. Okay. Now, next I want to define second divided difference. Okay. Second divided difference for x0, x1 and x2. Okay. x0, x1 and x2. So that can be written as f of x0, x1, x2, that is equal to f of x1, x2. Okay. This is equal to f of x1, x2 minus f of x0 x1 and divided by, now x1 is, you have to skip direct x2 minus x0. In denominator direct we have x2 minus x0, and that's why this f of x1 x2, that can be written as, sometimes we use this notation x1 x2 minus in bracket x0 x1, okay, in this big bracket upon x2 minus x0. Okay. So the second divided difference, we use this notation for x0, x1, x2. Similarly, if you want to define second divided difference on x1, x2, x3. Okay, x1, x2, x3. So now I hope you all can understand how we define a second divided difference on x1, x2, x3. That can be written as f of x1, x2. Sorry, f of x2, x3. Okay, f of x2, x3 minus f of x1, x2 and divided by x3 minus x1. Okay. Using this method also you can define third divided difference, fourth divided difference and so on. Okay. So to solve example, you have to remember this formula. Okay. Newton's divided difference interpolation formula. Newton's divided difference formula. Y is equal to, first one is a y0. Y0, don't forget y0 is nothing but f of x0. Plus x minus x0, x0, x1. So this is first divided difference on x0, x1. Okay, x minus x0, x minus x1 into, this is second divided difference x0, x1, x2. Okay, then x minus x0, x minus x1, x minus x2 up to x0, x1, x2, x3. Third divided difference of on x0, x1, x2, x3 and so on. Okay. The formula is quite tricky, but using example, I hope you all can understand that how we can solve the example. So let's try to solve some of the important example. Okay, first we just try to understand how we can make a divided difference table. Okay, forget about Newton's divided difference interpolation formula, how we can use in example. Just try to understand how we can define divided difference table. So here I want to find up to second divided difference. For the argument, the x is 1, 2, 5, 7. So the value of x is 1, 2, 5 and 7. Okay, and 7. Clear? Okay. And now f of x, the function is already given. F of x is x square. So 1 square, that is 1. 2 square that is 4, 5 square that is 25 and 7 square that is 49. Clear? Now first divided difference. Okay. See, first divided difference how you can make 4 minus 1 in numerator 4 minus 1 upon in denominator 2 minus 1. Okay. So here see 4 minus 1 upon 2 minus 1. So that is equal to 3. Now this entry that is nothing but 25 minus 4 upon 5 minus 2. Okay, 25 minus 4 upon 5 minus 2. So that is equal to 7. Okay, now this entry, let's try to understand this entry, that is 49 minus 25 and in denominator 7 minus 5. Okay, so that is equal to 12. Clear? Now try to understand the second divided difference table. That is, now you have to skip one entry in denominator. In numerator it's quite clear, 7 minus 3. See, in numerator we have 7 minus 3, but in denominator you have to skip this entry. So directly 5 minus 1. Okay, clear? 7 minus 3 upon 5 minus 1. Now next entry 12 in numerator it's quite easy to understand. Numerator it's quite easy to understand. The below entry minus the above entry. Okay, so 7 in numerator here 12 minus 7, 12. I want to explain this entry. So 12 minus 7, but now concentrate on this 3 entry, but you have to skip this one. So 7 minus 2 in denominator. Okay, so first here in denominator we just write 5 minus 1 here, 5 minus 1, and next 7 minus 2. Okay, clear? Very interesting. Okay, so first we skip this entry, direct just write 5 minus 1, and then we skip this entry, so 7 minus 2. Clear? And now 2 entry you have to skip in denominator. How you can get this 0? Because this 0 we get 1, this is nothing but 1 minus 1. Okay, I just write here this 0, that is equal to nothing but 1 minus 1, but in denominator you have 7 minus 1. Okay, 2 entry that you have to skip, direct 7 minus 1. Clear? Okay. Now from the following table find f of x using Newton's divided difference formula. Okay, interpolating polynomial that we have to find. So value of x is clearly 1, 2, 7, 8. So just I write 1, 2, 7, 8. Okay, f of x is already given, that 1, 5, 5, 4. Okay, now how we will get this 4? 4 is nothing but see, this is 5 minus 1. 4 is nothing but 5 minus 1 upon 2 minus 1 upon 2 minus 1. So 5 minus 1, 4, 2 minus 1, 1. So this is nothing but 4 by 1. Okay, so that's why we will get 4 here. Clear? Now how we will get 0? 5 minus 5 upon 7 minus 2. Okay, 0 is because of this equal to 5 minus 5 upon 7 minus 2. So numerator 5 minus 5 0 divided by 5. So that's why this is 0. Clear? Okay. Now minus 1. How we will get minus 1? Because 4 minus 5 minus 1, because of this equal to 4 minus 5 and upon 8 minus 7. Okay. So 8 minus 7. So 4 minus 5 minus 1, 8 minus 7 1. So that's why we will get minus 1. Okay. Now interesting. 0 minus 4, this entry, try to understand this entry. This is nothing but 0 minus 4 upon one entry that you have to skip. In denominator now you have 7 minus 1. Okay, so 7 minus 1. So minus 4 by 6, that's why we will get minus 2 by 3. Okay, minus 4 by 6, so that's why this is minus 2 by 3. Now try to understand this entry, minus 1 by 6. This equal to, because of minus 1 minus 0, minus 1 minus 0 upon 8 minus 2. Okay, sorry, 8 minus 2 in denominator. 8 minus 2, so minus 1 by 6. Clear? Now try to understand this last entry, minus 1 by 6 minus minus 2 by 3. So minus 1 by 6 minus 2 by 3. So plus 2 by 3 upon 8 minus 1. So 8 minus 1. So that is 7. So that's why this equal to, okay, take LCM. So minus 1 plus 4 and upon 6 into 7. Here this is minus 3 by 6 into 7. So 3. Here 2 minus 1 by, sorry, this is plus 3. Okay. So 3 by 14. 3 will be cancelled out. So final answer is 1 by 14. Okay. Clear? So that's why I hope you all can understand that how we first you have to make Newton's divided difference table. Okay. Divided difference table. Now we have to use all this diagonal entries. This is y0, so that is f of x0. This is my f of x0 x1. This is my f of x0 x1 x2. This entry my f of x0. Okay, this 1 by 14. This side f of x0 x1 x2 x3. Okay, so we have to use all this entry, all this values 1, 4, minus 2 by 3, 1 by 14. The formula is, first is, see this is my formula, Newton's divided difference formula. Okay, so first entry is f of x0, so that is 1, right? Then x minus 1, or second term x minus 1 into 4. Okay, x minus 1 into 4. The third term is x minus 1 is as it is, x minus 2 into minus 2 by 3. So x minus 1, x minus 2 into minus 2 by 3. Okay, then x minus 1, x minus 2, x minus 7, okay, into 1 by 14. So always this 8 is never used in this formula. The last entry of x is never used in the formula. Okay, remember, very important, always we use up to this. First in first term y0, that is 1, then x minus 1 into 4, then x minus 1, x minus 2 into minus 2 by 3, then x minus 1, x minus 2, x minus 7 into 1 by 14. So the last entry never used in the formula. Okay, now you can easily calculate, this is just a polynomial. Okay, x minus 1 into 4, so that is 4x minus 4, then minus 2 by 3 into, this is x minus 1 into x minus 2, so that you can easily calculate, simplify this 2 bracket. So x square minus 3x plus 2. Now x minus 1, x minus 2, x minus 7. The value of x minus 1 into x minus 2, that is already here. So just you have to multiply with x minus 7, you will get this third degree polynomial. Okay, and then take LCM and simplify. Okay, so final answer is, you don't need to take LCM in some case. Here you can see that you don't need to take LCM. Okay, you can take as it is your polynomial. So x cube by 14 minus 29 by 21 x square plus 107 by 14 x minus 16 by 3. Okay, let's try to solve one more example. Okay, here what is my x? X is 9. Okay, because I want to find, evaluate f of 9 using the following table. So the value of x is 5, 7, 11, 13, 17. Okay, so the value of x is 5, 7, 11, 13, 17. Okay, here the value of f of x is 150, 392, 1452, 2366, 5202. So I just mentioned the value of f of x here. Okay, this two table already given, this two column that you already given in the examination. Okay, now first divided difference, right? How you will get 121? 121 is nothing but, okay, 121 is nothing but 392 minus 150 upon 7 by minus 5. Okay, 392 minus 150 upon 7 minus 5. So this equal to 392 minus 150. So in denominator you have 2, and this is approximately 142. Sorry, 242. Okay, so that's why you will get 121. Okay. Now similarly, how we will get 265? 265 is nothing but 1452 minus 392 divided by 11 minus 7. Okay, 1452 minus 392 divided by 11 minus 7. This 457 is nothing but 2366 minus 1452 divided by 13 minus 11. This 709 is nothing but 5202 minus 2366 divided by 17 minus 30. Okay, clear? So easy to calculate. Now, how we will get 24? 24 is nothing but 265 minus 121. This is equal to 265 minus 121 divided by 11 minus 5. Okay, one entry that you have to skip. So 11 minus 5. That is 32 is nothing but, okay, 32 is nothing but 457 minus 265. 457 minus 265 upon one entry that you have to skip. Now 13 minus 7. Okay, so here 13 minus 7. So in denominator you have 6, and whatever the numerator value you will easily get 32. Now how we will get 42? 42 is nothing but 42, that is equal to 709. In numerator you have 709 minus 457 upon, now this 13 is missing. Okay, 13 is missing, so that is 17 minus 11. Okay, 17 minus 11, right? Easy to understand. And the last entry, because of in numerator you have 1 minus 1, 1 minus 1, and in denominator you have 17 minus 5. 17 minus 5. So numerator 1 minus 1, 0. Okay. And now we use this all diagonal entries. This is my y0, f of x0. This is f of x0, x1. Okay. F of x0, x1, x2. This is f of x0, x1, x2, x3. And this is f of x0, x1, x2, x3, x4. Okay. So this diagonal entry that we have to use for Newton's divided difference interpolation formula. The formula is like this one, that x minus 5. What is your x? X is 9. So 9 minus 5. 9 minus 5. Okay. The first entry is y0. So that is 150. 9 minus 5 into 121. Plus 9 minus 5, 9 minus 7 into 24. 9 minus 5, 9 minus 7 into 24. Okay, plus 9 minus 5, 9 minus 7, 9 minus 11 into 1. Okay, and plus 9 minus 5, 9 minus 7, 9 minus 11, 9 minus 13 into 0. So this last term becomes 0. You can easily calculate. Okay, this 9 minus 5, 4 into 121. This is 4 into 2 into 24. Okay, so this is the formula. Okay, as I told you, 150 plus 9 minus 5 into 121 plus 9 minus 5, 9 minus 7 into 24 plus 9 minus 5, 9 minus 7, 9 minus 11 into 1. And finally, you can easily calculate. That is the final answer. You will get 810. Okay. So in today's lecture, we discuss about Newton's divided difference interpolation formula. First, you have to understand what is divided difference, and then you have to understand that what is Newton's divided difference interpolation formula. So this first chapter is now complete. In this chapter, the important methods are: first, we have to understand what is interpolation. Then, our important relation between operators. There are 6 operators mainly. Forward difference operator, backward difference operator, central difference operator, then differential operator capital D, okay, then shifting operator E, and averaging operator mu, and relation between operators. So that is our first topic. Next topic is Newton's forward interpolation formula, and then backward interpolation formula, and Stirling interpolation formula. Okay, and lastly we discuss about Langrange interpolation formula and Newton's divided difference interpolation formula. Thank you.